Welcome back to the Unity Crash Course. Today I want to talk about another Unity topic that comes up when you're looking at scripting. This one is coroutines. What is a coroutine? A coroutine is a C# script that will be run piecemeal. The C# script for a coroutine is unique in that it doesn't complete. It runs a little bit of it and then it pauses and the game continues for a while, and then it returns back to where you were. This is very analogous to multi-threaded code, but it is not multi-threaded code. The coroutines do not run together in parallel with your regular update. They run alternately. So we'll do an update, a complete update, and then we'll run a coroutine. Now we won't run the entire coroutine. This is what's unique about a coroutine. We'll run a piece of the coroutine until you say in the code, you say stop now, and then it will pause the coroutine, and then on the next update it'll run the regular update and it'll return to your coroutine where it left off. There are numerous ways you can apply this concept, but the most obvious and my favorite way is when you have a sequence of things you need to wait in between. When you're waiting for something so that you can progress to the next step. Traditionally, we'll handle that sort of thing with just a basic state machine. I put together a little example here. Let's show. All I'm doing here is counting down 3, 2, 1, and then back up 1, 2, 3. And to handle that, let's take a look at the code. I have just a very simple state machine. I have two states. I have the count down state and the count up state. And I just have an update here. I'm running my update. I'm maintaining a timer. And every second, the timer ticks. And if you're in a count down state, I decrement my counter. And if you're in a count up state, I increment the counter. And when you hit the end point of the counter, I switch state. So this is a very basic, very typical sort of thing we do in video games. We'll have some sort of state that has to be updated and maintained frame to frame, and then something will happen that will advance us to the next state. What I'd like to do now is convert this into a coroutine. Remember, the idea of the coroutine is that instead of starting back at the top of the function every frame, I can have it pause in the middle of my function and come back to there on the next frame. So let's just convert this into a coroutine. Coroutines are of the type, they are functions that return the type enumerator, and we won't get into why. Let's call this update color. Won't take any arguments. Okay, the first step I want to do in the coroutine is I want to do a countdown 3, 2, 1. So let's just say mcount equals 3. We need to wait for 1 second. Let's go ahead and let's do this. We'll do this. We're going to count down just like we did. We'll start my timer at 1 second. Let's count down, and we're going to say while mtimer is greater than 0, we will decrement the timer and yield. What is this doing? This right here, I'm going to wait, like I said, I'm going to wait until the timer hits 0. And if the timer is not 0 yet, I just want to decrement the timer. The yield says pause. This is the pause of the coroutine that I promised. So that'll pause and it'll resume right there on the following frame. Yield return null. The null says there's nothing, right? So that the default behavior of the coroutine is just return on the following frame. So that's just call me back next frame. So on the next frame, we'll return here and we will ask again, is the timer greater than 0? If it's not, we'll decrement and move on. Okay, so that's my first count. Let's do that again. Let's say, how about while m count is greater than 0, we'll do this. We want to count down. We're going to have 3. We're going to run this for 1 second, decrement the count by 1. Run this for a second again, decrement the count again and again until the count hits 0. We do need to update that count number here. So each time the count is updated, no, we're going to put it, we can just put it right there. Okay. As soon as we get in here, right, we're going to set the text to the count, which will start at 3, and then we're going to wait for a second. It'll go to 2. We're going to wait for a second. It'll go to 1. We're going to wait for a second. Let's do this, greater than or equal 0, because I do want to go ahead and show the 0 for 1 second. All right, so this is my countdown completed. Let's do again. Now, after the countdown comes the count up. And that should be, we'll just start that with in fact, let's count down, count up. Okay, and we are going to do increase the count. So we're going to come in here, count is going to be -1. We're going to change the count to 1 because we already counted the 0. And we're going to count 1, 2, and less than 3. I don't want to do 3 twice. Okay, so I'm just going to do that, and that should be good. All I need now is to wrap this in a while true. I must do this forever. Okay, now that looks distinctly like an infinite loop, and really it is, but I have these yields in here. The yield will pause and then return there. So what am I doing is I'm just going to do my count down, and then I'm going to do my count up. And so far this doesn't look a whole lot better than what I had before. What I have done is I've gotten rid of the states because I don't have to return to the top every time. I know where I'm at in the program. I have my count down and I have my count up as separate blocks. And these yields will pause in between. Let's kick that coroutine off. First off, let's disable my old update. We don't want that running anymore. And let's now kick off the coroutine. We'll do that with start coroutine, and then just the function you want to call. We called it update co. There you go. And that will start running this coroutine. All right, let's see, how did I do? 1, 0, 1, 2, 3, 2, 1, 0. Excellent. Okay, so I converted it into a coroutine. Now, I'm not really expecting you to see this as a huge improvement, but let's take out a few of the support things we didn't need and show how that did make a slight improvement. We don't need that. Cool, there's a slight improvement. Let me also point out that this timer now is a local variable. So let's take the timer, and I'm going to take the M off of it, and I'm going to remove it and put it right there. Now, I'm wondering, is the count going to be accessible to other features? Maybe that count is important for something, but really count, the same thing applies to count. Currently, the count is not needed anywhere outside this function. And so we can see that we have cleaned up our members a little bit by making them local variables. Let's see that that still works. Okay, so the beauty of what we've done so far is we have eliminated some of the variables. We've really tightened that up and encapsulated the entire update process just in this one thing. The other thing I like about it is we don't need a state switch anymore. Since they're just a sequence, we can just program the sequence as if it was all happening immediately. And then we just insert those little yields whenever we want to break for a frame, for the next frame. Okay, let's take this to the next upgrade. The next upgrade here is this little timer wait. I want to wait for 1 second. And it turns out I don't always have to yield return null. I can return other things. What I return here tells Unity when to return. It says yield says pause, and what I return says when to return back to me, when to come back and call me again. And when I want to call back again is yield return new wait for seconds. I want to wait 1 second. And that's again here. Now I don't need the timer either. The timer is built in right here. I just say, give me a second. 3, 2, 1, 0, 1, 2, 3. All right, excellent. And so this is nicely cleaned up and very tight. I like this for sequence events, particularly like AI state machines sometimes can be a little unwieldy when, you know, it's just you got a character following a path. You're going to walk along a path. Step 1, turn towards the next path node. Step 2, walk forward. Keep asking, are you there yet? Are you there yet? Are you there yet? When you're there, advance to the next path node, right? You can code all that up, but in a standard update, you're going to have to start from the top each time. So you need to ask, which stage am I at right now? Which node am I on right now? You have to, you know, am I at the end yet? Blah, blah, blah. Doing it this way, it makes it linear. It's just a linear process because you don't have to keep returning to the top of the function each time. So I like that about it. And here's a good example of, you know, how that can work. There are other applications as well. Any time when you would normally be waiting for something, polling on something, you can use this coroutine to just periodically keep that going, keep an update just ticking off in the background, asking, are we there yet? Are we there yet? Or wait until we are there, that sort of thing. One last note about coroutines. Coroutines are not implemented as multi-threading. It feels like multi-threading because we have a program in a suspended state that isn't completed yet, but will continue over the next future frames while we have other code running. It feels multi-threaded. It is not. Unity's code is not thread safe. Just in general, all of it. If you're using any Unity-based code, like updating the transform of a game object, if you're referring to a game object and any of its Unity code, that is not thread safe, and coroutines do not use threads. They just run in between updates. So they take turns like every other update. Like the multiple updates for multiple characters are not handled in a multi-threaded parallel method. They just go one after the other. Coroutines work the same way. So that's our crash course on coroutines. They take a little getting used to, but they can be very helpful for cleaning up some code when you need to maintain an update or a sequence in particular, look for a coroutine possibly to handle that for you. All right, see you next time.